I asked for the antiderivative of e to the 4x dx. Think about that for 3 seconds. 3, 2, 1. Brianna, what's it going to be?
It's going to be 1 over 4 e to the 4x plus c.
Okay, excellent. What the heck is that? All right, antiderivative of 1 over 2 square roots of x dx. Think about that for 3 seconds. When you think you know the answer, raise your hand, please. 3, 2. Oh my God, only 2 people know the answer. 1 over 2 square roots of x dx. This is one that needs to be memorized. Needs to be memorized. Cassandra, what's it going to be?
I think it's square root of x plus c.
Square root of x plus c. Agree. All right, another one that you just need to know on site, the antiderivative of 1 over t dt. Only 4 people, 5 people, 6 people. Claudia, be careful.
The natural log of the absolute value of t.
Absolute value of t
Plus c.
plus c. All right, and one more before we do the fun stuff. Antiderivative sine pi t dt. Melissa.
Negative 1 over pi cosine pi t plus c.
Plus c. Is everybody mostly okay? Right, we've been doing these, we've been working with sort of strange problems where sometimes it's like e to the x plus e to the negative x squared. Thanks, Jessica. And you guys know, like, multiplication and exponents are bad. You multiply it out and you do your stuff and you're okay. Okay? So we've got the easy ones that you know on site. You've got the more challenging ones. Today, we are going from the slow lane of the calculus highway to the fast lane. It's going to be fast and furious. Buckle up. It's going to be okay. Yes, Paul Walker, God rest his soul. Okay, he will be with us. But before we go over there, I need to make sure that you've got your skills in place. We're going to go back. We're going to go back in time. We're going to go back to October. No. The good part of October. My birthday, Halloween, things like that.
Okay.
And back in October, one of the hardest things we were working on was the chain rule. Chain rule. You guys remember the chain rule? The chain rule is what you do when you have the derivative of a composition of function. I said composition, but really what you guys just heard was?
Function of a function.
Function of a function. Another way that we used to talk about it? We had the baby and we had the mama. And the baby lives inside of the mama. The baby likes to be warm inside. And if I said find the derivative of f of g of x, everybody would tell me that the derivative is?
Derivative of g of x.
So derivative of the mama.
Of g of x times
Leave the baby alone.
Times the derivative of the baby.
Times the derivative of the baby. We're good?
Yeah.
Okay, good. So I want to split up the group, make sure that you hear which ones you are doing. If you are in Salma's group, you're doing problems 1, 2, and 5. If you are in Melissa's group or Claudia's group, you are doing problems 2, 3, and 6. If you are in Abel's group or Cynthia's group, you guys are doing 2, 5, and 3. Don't ask me to repeat because I have no idea what I just told everybody to do. I just told you like 3, but it was specific. You have 4 minutes to find those derivatives. Show off with your derivative skills.
So you got Alright, so you got 2e5 sine. So we know here's okay, so we take 2 out, right? Because that's
Okay, careful. I like this.
No. Sine. Cos. Oh, yeah. Cos negative sine. We're doing the number 5 cosine.
And I understand what's happening in your head. You've memorized something, but you're using it the wrong way. The derivative of the sine is?
What do you mean? Like, exactly like that.
Why are you writing negative cosine? Okay. And Jessica, that is the most natural, normal thing that's going to happen. You're like, cosine, negative cosine, which one? Right? So maybe you just want to remember, you've got sine, cosine, negative cosine. And when you go this way, it's the derivative. When you're going this way, it's the antiderivative. Okay? Friends, how are we doing? Love. Love, 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 love. Where's your? Oh, now no. Hey, Magoo, get to work. I like it.
Oh,
I like it. Could be a little better.
But still, we're not going to set a derivative of the bottom.
It's a number, right?
Okay, so that's a little better.
Check to the number 5?
You want this times all the things that come out, right?
Oh wait, it's a number.
Otherwise, you're supposed to be.
Negative 1 over x.
Yes, ma'am.
Can we take the radical out?
1 over dash.
Do you take the radical out of the bottom? Holy jeepers!
No, it's just check.
Radicals in the denominator are okay.
-1.
Holy jeepers!
It is.
Because it's versus the way she's in the 1. Yeah, because it's basically just itself. I thought it was just e and then you take out the mother of negative 1.
So here's a model, right? Sine of x is you gotta bring down the chain rule. That you gotta bring down. E of negative e.
Yes, dear. I would.
No, we got 2 through 5.
Use a question.
Let it go. She's a good girl. She was not thinking that. Times parentheses. Parentheses. Don't like this one. All right, let's do it. Okay, real quick. We are not going to spend the whole day on the chain rule. We're going to spend like 5 more minutes on the chain rule because there's some reasons here. But look at number 1. Everyone's convinced chain rule?
Yes.
Okay, where's the baby? Where's the baby?
3x over 4 minus 6x.
Okay, the baby is right here because that baby likes to hide underneath the radical sign. So you've got the baby, and then you also have to identify the mama. And you guys were telling me that the mama is
Square root of x.
Square root of x. So over here, f prime of x, right? The derivative says, chain rule says, take the derivative of the mama. And this is one I wanted you to have memorized, Salma, so that you're not doing 14 pages worth of work. Derivative of the square root of x is
1 over 2 square roots of x.
Okay, I heard a couple of things. I heard 1 over 2 square roots of x. That's fine. I heard 1/2 x to the negative 1/2 power. That's fine. This is usually the easier way to go. Right, it's 1 over 2 times square root of the baby. And then times the derivative of the baby. Great. All right, next one, baby.
5
sin x.
sine of
Sin.
Sine of x.
Sine of x. My
3.
goodness. Sinning on.
Where's Josue?
Okay. If the baby is 5 sine of x plus 3, my question to you all is, what's the mama?
2e to the power of x.
Oh, so ugly. 2e to the x. So now I have to go over here and say, oh, I take the derivative of the mama, which is 2e to the x, and this is where the baby goes, right? So 2e to the 5 sine of x plus 3 times, Jessica, what's the derivative of the baby?
5 cosine of x.
5 times the cosine of x. Great. One more that I want us to talk about, number 5.
No.
Number 5. Is this a chain rule?
Yes.
I'm curious, how many of you guys see this as a chain rule problem? It's just a vision check. Some people see it as a chain rule. Anybody see it another way? Another way, another option. Brianna, what's your other option? Quotient rule works. Quotient rule works. Now, for my chain rule people, if it's the chain rule, where's the baby, where's the mama?
The baby is W to the 4th power plus 2W to the 3rd power.
And the mama?
1 over x.
Okay, 1 over x or 1 over w, depending on how you want to. Okay.
W.
Now, if you remember the derivative of 1 over x, this becomes really easy. The derivative of 1 over x is?
Negative 1 over x squared.
Negative 1 over x squared. So you've got negative 1 over baby squared. W to the 4th plus 2w cubed squared times derivative of the baby. 4w cubed plus 6w squared. And there's some simplifying and other things that we could do, but ultimately this is how it works. Is everybody okay?
Yeah.
Okay. Good. So let's flip this. So awkward. So awkward. Before we leave the chain rule, and there's a reason why we came back here. If you look at all of your answers, there is always somewhere in the process the baby and the derivative of the baby. Do you guys agree with that?
Yeah.
Okay. And so, Claudia, in this first one, where's the baby? If I just showed you the answer, and if I asked for the baby, where's the baby?
Inside the square root?
It's underneath that square root sign. There's the baby, and the derivative of the baby is where?
On the right side.
The right side over here. And seeing the baby and derivative of the baby makes me think, oh, this is a chain rule answer. And if I look down over here, where's the baby, Alejandro?
W cube plus 2w.
Wait, where?
Underneath the division sign.
Underneath the division sign. So like this guy over here makes you think baby, and this is the derivative of the baby. And again, that happens when your answer comes from a chain rule. All right, stay with me. We're about to jump over to the high-speed lane. I do not want to lose any of my ducklings here. Okay, when it comes to the chain rule, there are 6 places that you normally find the baby. Talk to somebody real quick. Identify as many of those places as you can. And let's be specific with the vocab here. Where do we find that baby? I can think of 6 places.
Inside.
Cancel parentheses.
Between parentheses? Yeah.
Oh, I'm about to rock your worlds. I can't wait. All right, so let's get some hands on this. Where can you find the baby in a chain rule problem? Baby, Melissa, where's one place? In the exponent, right? The baby likes to hide in the exponent. Always in the exponent? No, what are the options? Brianna, where else?
If it's being squared.
Okay, if you have something being squared, right, the thing that is getting squared is possibly the baby. Where else does that baby hide? Where else have we seen the baby hide? Claudia, where else?
The denominator?
Sometimes in the denominator, right, that's where the baby likes to hide. Where else? There's more places. Underneath the radical sign, like a square root or a cubed root. Where else?
The side?
The what?
To the side?
To the side. Baby on the side?
Like, you have one, the mom, then the side.
As an angle.
Oh, I kind of see where you're going. One more time.
As an angle.
As the angle, like when you say sine of the angle is often the baby. So I would say the denominator, the exponent. Where else did we say? Underneath the radical sign?
Parentheses.
Inside the parentheses. There you go. So we've got denominator, we've got in the exponent, we've got in the radical, inside parentheses. It's the angle. These are places where we can find the baby. Pretty good? I'm sure there are 6. I can't remember what the last one is. Brianna?
Couldn't it be if it's, in between the absolute value?
Right, if you're taking like the absolute value of something, that would be a place, and that counts for 6. So we're going to move on. All right. I want you to keep that in mind as I blow your mind. Just be prepared for your mind to be blown. Exhibit A. Look at this integral. Oh my God, how exciting is this? Your future college acceptances are based on whether or not you can solve this problem. The problem says find the antiderivative of x to the 4th minus 3x squared to the 5th times 4x cubed minus 6x. Have a quick strategy conversation. What would you do? If time was not the obstacle, if you had all the time in the world, what would you do to make sure you came up with the right answer?
Constant erosion,
I would create a calculator.
go to the cemetery, make a hole for myself.
Then I would know that
What's coming out of the
here around here. Normal would be.
Can't we just like
Yeah, that's what I was doing.
change it?
Isn't this one the antiderivative?
Make that double.
Wait,
Okay, yeah, I agree. Yeah. So then, that would be actually.
All right, so I've heard, I can get you guys to stop. I've heard one recommendation, which is I would take this x to the 4th minus 3x squared to the 5th, and I would make a box. And say it's x to the 4th minus 3x squared times x to the 4th minus 3x squared, multiply it out. And then what do you have to do?
Again.
Do it again. And then?
Again.
Again. And then multiply by 4x cubed minus 6x. Now that's not bad, you know, like that will work. That gets you around multiplication, because multiplication is bad news in the integram. You see that, you know it's a problem. But there's a more elegant way if you see it. And rather than asking if anybody sees it, I'm going to encourage you to look at this problem with fresh eyes. Okay. I want you to look at this as though it is the answer to a chain rule problem. If it is the answer to a chain rule problem, there is a baby hiding in here. And the derivative of the baby. Do we see a baby?
Yes.
Okay, Brianna, where's the baby?
The baby is in the parentheses for the 5th.
This guy in here
Yeah.
could be the baby. I'm saying could be the baby. Could be the baby. If this is the baby, do you also see the derivative of the baby?
Yes.
The baby, right? If this is your baby, x to the 4th minus 3x squared, the derivative would be 4x cubed minus 6x.
Yep.
This is the derivative of the baby. This is good news for us. And here's the new technique. Just let me go through it this one time, and then I'll take any and all questions. I'm going to give myself lots of room here. X to the 4th minus 3x squared to the 5th times 4x cubed minus 6x dx. What I'm going to do, it's called substitution. The goal is to make this problem easier to work with by saying, you know what, if this is what I think the baby is, rewrite it. I'm just going to say every time I would normally be writing x to the 4th minus 3x squared, call this u. You guys have done this before last year with like Salhotra when he taught like the trig stuff. You guys would do that, and that was great. Now here's the thing though. In calc, not only do you identify the baby, you then need to find the derivative of the baby. So this first step is about identification of the baby. This part here is baby prime. What's the derivative of the baby? 4x cubed minus 6x. Now, have faith in me. Know that I am not lying to you. Here's what we're going to do. I am going to say, well, if du divided by dx, the derivative of u with respect to x equals 4x cubed minus 6x, then it's also true that du equals 4x cubed minus 6x times dx. Basically, I'm multiplying both sides by dx using my fraction killer skills. Okay? What I'm going to do is rewrite the original integral without using the letter x. I want to use u instead. So look at this. I've got x to the fourth minus 3x squared to the fifth, but this is what we're calling u. I've got u to the fifth. I have 4x cubed minus 6x times dx. Hey, 4x cubed minus 6x times dx, that's du. By this careful selection of the baby, by finding the derivative of the baby, I'm able to rewrite the integral in a much more compact way. This is not the answer. This is the same integral, just boiled down into a much easier to see form. And if I asked you guys, what's the antiderivative of u to the fifth?
1/6.
It would be 1/6
U to the 6th.
u to the sixth plus c. You're doing the substitution to get something smaller, more compact, easier to integrate, and then you're doing the integration. Now the mistake I want you to avoid is stopping here and thinking this is the answer. Because this is the trouble some of you guys got into in pre-calc last year when it came to the common assessment. This isn't the answer. Why not?
Put U back in.
The problem was in terms of x's, you gotta get me back to being in terms of x's. So don't stop at 1/6 u to the 6th plus c. Make it 1/6 times x to the 4th minus 3x squared to the 6th plus c. Questions? This is gonna feel like magic for a while.
Okay, where do we go after that?
Okay. I would go to the next problem.
Oh, okay.
Because the question being asked here is what function has all this stuff as its derivative? And so you say, all right, here it is. Now, is this really the right answer? Hopefully it is. Hopefully I'm not lying to you. But Abel, if I wanted you to know for sure that this was the answer, or even better, let's say that this shows up on the multiple choice part of the test. And this is one of the answer choices, but you forget how to do this beautiful substitution. If this is one of the answer choices, how could you make sure that this was right?
Use the power rule
You use the power rule to do what?
to try to get back to where you started.
To find the derivative and get back over here. Right, you could check it by saying, let me take the derivative. Do I get all this stuff back? Well, the derivative of 1/6, the stuff to the 6th power, you'd bring the 6 down in front. 1/6 times 6 is 1. The baby, not 5 squared, the baby now raised to the 5th power, like it, don't stop though, times baby prime. This is baby prime. Okay? Jasmine?
Do we have to go through that whole process because I noticed that it was a derivative, so we didn't really need it and it was gonna be inside.
There are going to be some of you who are going to see, kind of like look at this like I do, and you just see it right away. If you see it right away and you think you can make it show up on your own, go for it. But I'll tell you, this is like a foolproof process. Yeah.
So what I'm noticing in that one is like one of the antiderivative that you might have memorized.
Yep.
The 1 over n plus 1 sine
Yep.
of x over n.
Yep.
Is that the same thing that's happening there?
That's exactly what just happened over here, except instead of x's, it's u's. Okay? Try the second one. Have a strategy conversation with somebody near you. Go as far as you can. We'll talk in a minute. What you're looking for is the baby and the derivative of the baby. Once you lock in on that, you're in a good place. Any guesses for the baby here? Any guesses? Cassandra, where do you think the baby is? Okay, is that one of the places the baby likes to hide? Yes. Okay, so I might say my baby, or really I'm not going to call it the baby. I'm going to say, okay, that's u. So I'm doing the integral of 10e to the 5 sine of x times cosine of x dx. you said u is equal to 5 sine of x. If that's right, it might be right, it might be wrong. What's the next move, Alejandro?
Find the derivative.
Find the derivative. And I want to be careful with my notation. If you're saying u equals 5 sine of x, then it's the derivative of u with respect to x. So du dx is equal to, what is that, 5 cosine of x? Okay, that's good. The next thing that you're going to do is we're going to multiply by dx. So we're saying that du is equal to 5 times the cosine of x times dx. Yes, ma'am?
Why did you put 5 cosine of x? You only had cos.
Huh?
For the derivative?
Okay, but if I asked you to find the derivative of 5 times sine of x, the only right answer for the derivative is 5 times the cosine of x. I see what your problem is. You're seeing just the cosine of x over here? Stay with me. Is everybody okay? Okay. Look at your integral. If I'm going to go and I'm going to rewrite this, I've got 10 times e to the u times cosine of x and the dx. I've rewritten this middle part, but I still have 10 cosine of x dx. What I know is that du is equal to 5 times cosine of x dx. What I have in my integrand is 10 cosine of x dx. Trust the instincts here. If what I have in the integrand is 10 cosine of x dx, and my work over here says that du is equal to 5 cosine of x dx, then if I multiply both sides here by 2, then I know that 2 du is equal to 10 cosine of x dx. So I can rewrite my integral over here, instead of 10 e to the 5 sine x cosine of x dx, just take the 10, the cosine of x dx, and replace it with 2 du. 10 cosine of x dx, that's actually like just double what du is. The e to the 5 sine of x, that's the e to the u piece. This is not your final answer. You need to integrate. Nice things that you can do, nice legal things you can do to make life better. I've got e to the u times 2 du. That 2 is a constant. I can take it out. So I've got 2 times the integral of e to the u du. And I bet some of you guys are seeing it now. This should be an answer that you know right away. The antiderivative of e to the u. What would have e to the u as its derivative?
E to the u.
E to the u. So your answer is going to be 2 e to the u plus c, almost. You've got to make sure you go back to your original variable. Instead of 2 e to the u, you're going to say it's 2 e to the, what is that, 5 sine of x plus c. And before I box it and I'm like, yeah, I've got it, take a minute and check this. And what do I mean by check? I mean take the derivative. Go take the derivative. If you take the derivative in the right way, are you getting 10 e to the 5 sine x times cosine of x? What questions are out there? It's okay. Melissa?
For the 10,
Yep.
oh yeah, why can't you put 10 EQ times something?
So why 2 e to the u instead of 10 e to the u?
Yeah.
Okay. So you're okay with, we identified the baby as 5 sine of x? Once you take the derivative, you're stuck here. You have to find the derivative in the right way. The derivative would say the derivative with respect to x is 5 times the cosine of x. When I rewrite by multiplying by the dx, du is 5 cosine of x dx. So anytime I see 5 cosine of x dx, that's worth 1 du. What I have in my integrand is 10 cosine of x dx. It's double what I have over here. So I double the du. 1 du equals 5 cosine of x dx, so I double both sides to get to the 2 du. All right, try number 3. Let's see what you can do. Looking for the baby and the derivative of the baby. Where's that baby? If this is the answer of the chain rule. Here's how many of you guys think you found the baby? That looks like nobody right now. The baby likes to hide in 6 different places. Exponents, angles, in parentheses. Cassandra, where do you think the baby is? Is at 5t, so you're thinking like the baby is the baby's the exponent? Remember, you're looking for the baby and the derivative of the baby at the same time. You need both to show up here. Salma, where do you think?
E to the 5t.
E to the 5t. So if e to the 5t is the baby, well, what's the derivative of the baby?
5t.
Uh-oh. E to the 5t times 5 would be the derivative because you need a chain rule. Okay? So maybe it's e to the 5t. I will tell you what the baby really is the entire denominator. We're going to get a lot of practice over the next couple of days with identifying this baby, but trust the process. If the baby is this e to the 5t plus e squared, if this is the right baby, your next move, find the derivative. So we're going to find the derivative. We're going to find du, be careful,
T.
t. I need the derivative of e to the 5t plus e squared. Derivative of e to the 5t is e to the 5t times 5 plus the derivative of e squared. Careful, I think someone's thinking e squared. What's the derivative of e squared? What's the derivative of e squared? Not 1? Nope. Janaea, what's the derivative of e squared? Why?
Because since there's no variable at the top, that means it's just going to be.
There's no variable involved here. E squared is a constant, so the derivative of e squared is 0. So let's keep going with this. Du dt, the derivative of u with respect to t is e to the 5t times 5. That's the same thing as saying du equals, I'm going to write the 5 in front if that's okay. 5 e to the 5t times dt. If du is equal to 5 e to the 5t dt, Melissa, we're kind of coming back to the question you had before. Du is equal to 5 e to the 5t dt. What I have in my integrand is e to the 5t times dt. Not 5 times e to the 5t, just 1 times e to the 5t dt. What I can do is I can multiply both sides by 1/5. If I multiply by 1/5, then 1/5 du is equal to e to the 5t dt. when I go up here to rewrite the integral, instead of e to the 5t and dt, I'm going to write 1/5 du. Instead of e to the 5t plus e squared, that's what u is. I'm trying to find the antiderivative of 1/5 du over u. Let me stop here because you guys have question face. Alejandro, what's up?
How did you know to divide by u?
How did I know to divide by u? Because my original integrand was e to the 5t divided by the thing I'm calling the baby. Right? All we're doing is we're renaming this guy here as u to get it into that right form. So I've got 1/5 du over u. Good question. Salma.
So we have to, so that whole thing that we just did, we have to find a way to get u into the derivative from the top?
Not just the u, but the du. I'm trying to rewrite this whole thing as a combination of u and du.
Yeah, but we have to get like du from u, so that's why we multiply it.
Right, so you first identify the baby, then you go and you find the derivative. Okay? Stay with me. We've got 1/5 du over u. I want to find the antiderivative here. The legal thing that I can do that would make life so much better, and we're like 30 seconds away. Miguel, what do you say?
Break it up.
What do you mean by break it up?
So it'll be 1/5 times 1 over u.
Okay, and I can take that 1/5 out because it's a constant. So 1/5, I heard you say like times 1 over u. That ought to be something that's much more familiar and much easier to work with. Antiderivative of 1 over u du.
I should either add the
Right, this has to be 1/5 natural log absolute value of u plus Charlie. And before you finish, before you think, I've got it, you got to replace. So this is 1/5 the natural log of the absolute value of e to the 5t plus e squared plus Charlie. And before anybody hits the panic button, tonight's homework has nothing to do with integration by substitution. We're not ready for that yet. Tomorrow we're just going to get a heavy practice day. The nice thing is once you figure it out, it is just going to be a process that works almost all the time. Thanks for listening there. All right, here's what I want you guys to do. We've got 10 minutes. That should be enough time to tackle 3 of the problems on page 3. Any 3 of these 5 would be great practice. If you've got any questions, things that aren't clear, now would be a good time to ask those.
easier way to do it.
This is the easy way. Trust me, with practice, it'll click. Derivative of the baby. So the part that I guess you didn't get copied down, u is equal to e to the 5t plus e squared. The next thing is to say that du over dt is equal to e to the 5t plus 0, and then you multiply by dt. So Jessica, what's your, if you were just going to make a guess about the baby, okay, so if that's the baby, do you see the derivative of the baby? chose the baby well. Curious for the folks that are on number 1, did everybody pick x squared plus 9 as the baby? Okay, hopefully the choice of the baby is somewhat obvious right now. So then the next move?
du.
You're going to go and find the derivative, right? Find the du dx, and the derivative is
2x plus
just 2x. If u is x squared plus 9, then the derivative is just 2x. Okay. Now, the issue is like, well, where's this 8x coming from? Right? If the 8x, if your integrand is 8x times x squared plus 9 to the 5th, I've already found, because of the way that you guys chose the baby, you found a way to write the u to the 5th. It's just a matter of what about this 8x and the dx? Well, if du dx is 2x, and that's the same thing if I multiply both sides by dx to say that du is 2x dx. Jessica, do you know a way to make this 8x dx? Is that legal? Is it legal to multiply this by 4? Yeah. Absolutely, as long as you also multiply on the left. So what we're going to say is now 4 du equals 8x dx. So in your integrand, if you have 8x dx, we're going to rewrite that as 4 times du. So we've got 4 du. The integral of u to the 5th times 4 du. Maybe you like it in that form, maybe you don't. I would clean it up a little bit if that makes life better. For example, taking that 4 out in front. It's a constant, that's legal. And now the question is just, what's the antiderivative of u to the 5th power? Right, u to the 5th power. How do I integrate something raised to the 5th power?
1 over n plus 1.
Right, you add 1 to the power. You divide by the new power. So 4 times 1/6 u to the 6th plus c. If you want, you can simplify it. 4 times the 6 is 4/6. That's really 2/3.
I have a question. When do you stop putting the integral sign?
When do you stop putting the integral sign? You stop putting the integral sign like right in this move, because this is where you're actually finding the antiderivative. You're saying, I know how to find the antiderivative of u to the 5th. It's this 1/6 u to the 6th. That's when you'd stop. Once you find the antiderivative. If you haven't started on number 2 yet, I want to change the coefficients. Make that 6x squared plus 12 instead of 5x squared plus 10. I think I was just being mean. Go for 6x squared plus 12 instead.
Yeah, 105 more days to calculate that.
No, 105 more days until the AP exam, and then we have extra innings after that.
I don't like overtime.
Just keep going. The way you're going to know you chose the right baby, if that's the baby, what's the derivative? 3x squared plus 6. Do you see in the integram 3x squared plus 6, or something that you can get using 3x squared plus 6? If you double that 3x squared plus 6, you'll get the 6x squared plus 12. Good choice. You okay there? Where? So once you identify the baby, the other thing you need to think about is the derivative of the baby. So if u is 6x squared plus 12, your derivative is 12x. Look at all the stuff you still have here in the integrand. You've got e to the x cubed plus 6x plus 1. That's a whole lot. And my derivative here is just 12x. I would switch it. Try the exponent as the baby. Baby, looking good, doubled. Do you know why you're double?
Is it because of the 6x that it's looking?
One more time.
Is it because of the 6x or the 12?
It's not because of the 6x, it's because of the whole thing in front. It should be 6x squared plus 12.
Oh. Is it 2 including the baby?
Maybe. Maybe. Okay, so tomorrow and Monday we are going to keep playing around with integration by substitution.